Thanks for watching Edupedia World videos. In this video, we'll be discussing solutions to problems in the second paper of the 2013 JEE Physics Advanced Question Paper. I'll be working with code 0, but in any other codes the question will be the same, just the order will be shuffled, so you can figure that out for yourself. The first question in my paper has the examiner give you the graph of the specific heat versus the temperature, C versus T, which is something like this. This is 400, this is 0, this is 100, 200, 300, 500. So we know that dq is equal to mc dt, right? Or the standard definition of C, which is dq by dt is equal to mc. So this is basically the curve of the slope of the q versus t graph, right? The slope of the q versus t graph initially is 0, and then it is increasing, and finally it reaches a constant value, right? So let's look at all the options. Now when there are more or one choices correct, the best way to do it is to look at each option as a true or false option. So let's look at option A. Option A says that the rate at which heat is absorbed in the range 0 to 100 varies linearly. Rate at which heat is absorbed proportional to mc. So the option is saying that between 0 and 100 mc varies linearly, and you can see that from the graph. This is a pretty linear graph, right? So A is true. Then B says heat absorbed and increasing from 0 to 100 is less than that from 400 to 500. So from 0 to 100 C is smaller than it is from 400 to 500. So the slope is smaller. Not only that, but dt is the same, right? Here it's a difference of 100 degrees, here is a difference of 100 degrees, right? So obviously dq will be smaller in 0 to 100 than it is in 400 to 500, right? So the second statement is also true. The third statement, no change in rate of heat absorption in 400 to 500. Rate of heat absorption is mc, right? The rate of heat absorption is dq by dt, which is mc. Between 400 to 500 it does not change. So this is also true. And option D says rate of heat absorption increases in 200 to 300. From 200 to 300 it's not linear, but it is still increasing. So this is also true, which means the answer to the first question is A, B, C, D. All four are true, right? Let's move on to the next question. The radius of the orbit of an electron is 4.5 a0. We already know what the radius is. It is a0 into n square by z, and that is given to us to be 9 by 2 a0, right? Also, angular momentum is 3h by 2 pi. Angular momentum, which is generally nh by 2 pi, is equal to 3h by 2 pi, which means n is equal to 3. Which means if n is 3, n by z is 9 by 2, z is equal to 2. Now we are asked the possible wavelengths when it de-excites. What are the possible wavelengths? 1 by lambda is equal to rz square 1 by n1 square minus 1 by n2 square, right? What is z? Z is 2, so rz square is 4r. Now let's look at these terms. We have 1, 2 and 3. It is at n is equal to 3 right now, and we are given that it de-excites. De-excites means falling to a lower energy level. It either falls to 2 or it falls to 1. If it falls to 2, we'll have 1 by lambda is equal to 4r times 1 by 4 minus 1 by 9, which is 4r times 5 by 36, which means lambda is 9 by 5r. And if it is 1, then we have 1 by lambda is equal to 4r times 1 minus 1 by 9, which is 4r times 8 by 9, which means lambda is 9 by 32R. So these are the two possible answers, 9 by 5R and 9 by 32R. So that means the answer is A and C. Question 3. We are given Bragg's law, which is 2d sine theta is equal to lambda. Right. Calculate the values of d by measuring theta in the range 0 to 90. Lambda is exactly known, then, and the error in theta is constant for all values of theta. As theta increases, what about the error in d? So we are talking about errors, so let's just differentiate this equation directly. This will give us delta lambda is equal to 2 times delta d times sine theta plus 2d cos theta times delta theta. And we are given that this is 0 because lambda is exactly known, so delta lambda is 0, which means delta d sine theta is equal to minus d cos theta delta theta, which means delta d by d is equal to minus cot theta delta theta. And we already know d is lambda by 2 sine theta, so delta d becomes minus cot theta delta theta into lambda by 2 sine theta, which is minus lambda delta theta by 2 cos theta by sine square theta. So we have both formulas, delta d by d and d. Delta d by d is the fractional error in d and delta d is the absolute error in d. Right. As theta goes from 0 to 90 degree, sine theta increases and cos theta decreases, which means that cot theta decreases. Right, and whenever we don't let the minus sign confuse you. Whenever we talk about errors, we talk about magnitude. So let's forget the minus sign. Right, mod of this is plus and mod of this is plus. Right, or plus or minus, whatever, depending on what the sign is. We're just concerned about magnitude. So as theta goes from 0 to 90 degree, cos theta decreases and sine theta increases. So cot theta decreases. That means the fractional error in d decreases. What about the actual error? Well, the actual error decreases as well because cos theta decreases, sine theta increases. Delta theta is a constant for theta. So both the fractional error and the absolute error decrease. The absolute error decreases is not an option, but D option says the fractional error decreases. So D option is true. Right? Question 4. We are given two spheres with an overlapping region. One of them has rho, the other one is minus rho. So let's take a random point in the middle. We know that the electric field within a solid sphere is given by rho r by 3 epsilon naught. R is the vector along with the direction. Right? So rho r by 3 epsilon naught. Let's say this vector is r plus and this vector is r minus. So the net electric field will be rho r plus by 3 epsilon naught plus rho r minus by 3 epsilon naught. Right, but what is the sum of these two vectors? It is this vector. Let's call it a constant d vector, which is the vector from the center of one to the center of the other. So it is equal to rho d by 3 epsilon naught, which means the electric field within this overlapping region is constant in both magnitude and direction because d is a constant vector. Right. So electric field is both constant in magnitude and direction. That does not mean the electric field is zero. It does not mean the potential is constant, but it does mean that options C and D are true. So the answer in this case will be C and D. Let's move on to question 5. a steady current is flowing along a hollow cylindrical conductor. So let's say this is a cylindrical conductor. A steady current is I is flowing along the surface. And then we put it inside a solenoid of radius 2r. I'll not be able to draw the figure properly, but this is the solenoid of radius 2r. Now let's look at the magnetic fields due to both of them first. Let's say this is r and this is 2r. Inside the solenoid, first of all, the magnetic field will be along the axis everywhere due to the solenoid. Right, so the solenoid will have its component that is towards the axis everywhere inside and 0 outside. That is the solenoid. What about this cylinder? Inside, the current due to this cylinder will be 0 because you draw an Amperian loop and there will be no current enclosed. So inside, the current due to this cylinder is 0. Outside, what is it? It is like a wire. It is circumferential. So outside, the magnetic field will be like this, circumferential. So between 0 and r, cylinder gives 0, you have towards the axis. Between r and 2r, you have both. You have towards the axis due to the solenoid and circumferential due to the conductor. And outside, you only have circumferential due to the conductor. So option A says in 0 to r magnetic field is non-zero. That is correct. It is 0 due to the conductor, but the solenoid does have some magnetic field. So A is true. B says between r and 2r the magnetic field is along the common axis. No. The magnetic field due to the solenoid is along the common axis, but the conductor also has a component which is tangential, circumferential, right, in this direction. So therefore B is false. In r to 2r, magnetic field is tangential to a circle. That is also false. It is a resultant of a tangential field and a field along the common axis. And in r greater than 2r, the field is non-zero. Yes, outside the field due to the solenoid is 0, but the field due to the cylinder is circumferential, so it's non-zero. So the answer is A and D. Question 6. We are given two vehicles moving with the speed u each. So this is one vehicle moving with the speed u. This is the other vehicle moving with the speed u. Wind blows along the road with a velocity w. Right, so it's either in this direction or in this, but it doesn't matter because these are arbitrary. Let's just take wind in this direction with the speed w. Right, and the speed of sound in still air is v. That is the speed of sound. And one of these vehicles blows a whistle of frequency f1 and the other one here's a frequency f2. What is the correct option? Now there are two cases. One of them is that this one blows the whistle and this one hears it. In the other case, this one blows and this one hears it. And we'll have to do both of them. So the first case, let's take it such that the first one, let's call this A and this B. A blows the whistle, so A is the source. And in the second case, we'll take B is the source and A would be the observer. Right, so you take A and B as the sources. If A is the source, now again these types of problems you can solve in two ways. You can solve them either in the ground frame or in the air frame, and I'll just show you from both of them in one step that the equation comes out to be the same. If you are doing it in the ground frame, then if this is the speed of the wind, w, then the speed of the sound just becomes w plus v, right? This is the source, this is the observer, sound is going in this direction. It would have gone with the speed v, but now it's going with the speed v plus w. So our standard equation will be v f2 is equal to v plus w minus u by v plus w. So this will be plus u because they are going towards each other, so the frequency will increase, minus u times f1. Right, this is the equation. Now what would we do in this is the ground frame. What we do in the air frame? In the air frame the equation is still the same. What do we do in the air frame? The velocity of the wind is v, so get v plus by v minus and f1. But what are these terms now? In the frame of the air, this is not going forward with the speed u. This is going forward with the speed u minus w, right? So u minus w, speed of the source. And this is coming towards with the speed u plus w in the frame of the wind. So plus u plus w. And you see that the answer, the equation in both cases is exactly the same. So you can solve these questions either in the ground frame or the air frame, doesn't matter. In the second case, if this is the source, then you would have F2 is equal to, I'll just solve it with the first method. Now the speed will be capital V minus W because the sound is going in this direction. So V minus W, they're going towards each other. So again, it will increase the frequency plus U by V minus W minus U times F1. Right. So in both cases, we can actually see that V minus W or V plus W is a constant, but there is a plus U and there is a minus U. So the frequency is increasing in both cases. Right. F2 is greater than F1 in both cases. So the answer will be A and B. Seven. You have two masses, capital M, separated by a distance 2L, and small m is projected from the midpoint with a speed v, whatever the speed v is, perpendicular to the line. What are the correct statements? So the first three options relate to what is the escape speed. So initially, what is the energy of this object? The kinetic energy is half mv squared, and the gravitational potential energy is minus 2 into gmm by L squared. If this energy is greater than 0, it will escape. So for it to just escape, it should be equal to 0. Small m cancels, which gives me V is equal to 2, sorry, this should be gm by L only because we're talking about energy. 2 root of gm by L. So obviously out of A, B and C, option B is correct. And option D is obviously correct because gravitational force is a conservative force. So the total energy will remain constant. Right. If there was some friction or something, then the total energy would not have been constant. A particle of mass m attached to a spring of spring constant k, the other end is fixed horizontally with a speed u. Okay. So I'll not draw the spring just because it makes the image a little bit unclear. So the object is oscillating, this is x is equal to 0. Right. It is moving and it would ordinarily move like this. However, a point here, it did not get to go to this point. Right. It was here when the speed was u by 2. Right now it's u0. When the speed is u0 by 2, it hits the wall elastically. Now the wall is rigid, so obviously the velocities of separation has to be equal to approach. So it will come back with u0 by 2. And then it will move on its normal way and go back till this point because the kinetic energy is still the same. So that is what is going to happen. So option A, which says that the speed of the particle when it returns to equilibrium position is u0, that is true. It is going with u0. Basically what has happened is we removed this part and condensed it into a single instant. So the things relating to time will change, but if it's going with u0, here it's u0 by 2, the wall makes it u0 by 2 backwards. If it is u0 by 2 in this direction, after it comes here, then it's going to be u0 here. So it will be u0 in this condition as well. If this was a partially elastic collision, then this would not be true, but now this is true. B option says that the time at which the particle passes through equilibrium is pi root m by k. No, that is not true. That would be true if it went through the whole path and came back, but it only went through a portion of the path. So the time will actually be small. Right, smaller than that. So B is false. C, the time at which maximum compression occurs is 4 pi by 3. Maximum compression occurs when it is at the center. Right. So now we'll have to calculate properly. So if the equation is x is equal to a sine omega t, because we can't directly say if 4 pi by 3 is wrong. If the equation is a sine omega t, then speed or v will be a omega cos omega t. And when is it equal to a omega by 2? Maximum speed is a omega. When omega t is equal to pi by 3 or t is equal to pi by 3 omega. Pi by 3 omega. And since 2 pi by omega is the total time period, this is equal to t by 6. Right, 2 pi by omega is the total time period, so omega is equal to 2 pi by t, so t by 6. Now just let's write that. This is t by 6. Coming back is t by 6. This is t by 4, this is t by 4. If it were t by 4, then all 4 total time would be t, but it's smaller than that. So when does the maximum compression occur? It occurs at 2t by 6, that is at time t by 3. T by 3 is not 4 pi by 3 root m by k. T by 3 is, t is 2 pi by omega, so it is 2 pi by 3 omega, 2 pi by 3 root m by k, which is not 4 pi by 3 root m by k. So C is wrong. C false. D, the time at which it passes through the equilibrium position for the second time. That means it goes and comes back and goes and comes back. So the total time will be this time 2 pi by 3 root m by k plus half a time period. Right, t by 4 plus t by 4. So that is plus pi root m by k. So 5 pi by 3 root m by k. So option D is true. Which means the answer to this is A and D. Now 9 and 10 are comprehension type questions. They are based on the same passage, in which we have a circular arc of radius r. This is point P and this is point Q, 30 degrees, and we leave a block here. And we've actually drawn the axis in this case, which makes things a little bit simpler. This is the x-axis and this is the y-axis. So the mass of the block is 1 kg. It is released from rest at the top of a rough track. Radius is 40 meters. And it slides without toppling and a frictional force in the direction opposite to its instantaneous velocity. The work done overcoming friction to a point Q is 150 joules. That means the work done off friction is minus 150 joules. That means the work done in overcoming it is 150 joules. Speed of the block when it reaches Q. What is the work done by gravity? It is m, that is 1 into g into this height. What is this height? 40 sine 30. Right, because this is radius r 40, this is 40 sine 30, so this is 20, is equal to 200 joules. And work against friction is 150 joules. Right, because due to friction is 150. So what is left? That is 50 joules. 50 joules is left for the kinetic energy, which is half into 1 into v square. V square is 100, or v is equal to 10. Which means the answer to 9 is B. Let's look at the 10th one. What is a normal reaction at Q? Right, so what is the normal reaction at Q? So now we know V, that is 10. So we can write the equation in this direction. Right, now we know the acceleration in this direction. We don't know acceleration in the vertical direction or anything particular, but we do know it in this direction. So if this is mg, this is 60, so this is 60. So mg cos 60, that is 1 into 10 into cos 60, which is 1 by 2. N minus this is equal to mv square by r, 1 into 100 by 40, which means n is equal to, this is 5 by 2, 5 plus 5 by 2 is 7.5. So this is the answer to the 10th question A. 9th question B, 10th question. This was one of the easier questions in this paper, a standard mechanics problem, nothing too complicated about it. Now let's look at the next paragraph, 11 and 12. They are about transformers and current being transmitted. So the thermal power plant produces electric power at 600 kilowatts, so 600 into 10 to the power 3 SI units, and the potential is 4000 volts. It is transported to a place 20 kilometers away, and it can be transmitted directly or by using step up and step down transformers. So what happens is, because the power and the voltage are fixed, the current will be fixed, and this is the voltage at which it is being produced. This is not the voltage at which it is being necessarily transmitted. So from this you get a particular current. I square R is the power dissipated. So the greater the current is, the more power will be dissipated. So in order to decrease current, we can increase this potential by using a step-up transformer, increase potential, then transmit it to reduce loss of energy, then decrease potential again, right? So first we're doing it on the first method, and then by doing using transformers. So in the direct transmission, the power dissipation percentage is asked, right? So from these two we can get I is equal to P by V, which is 10 to the power 3 cancels with this, 600 by 4 is 150 amperes, right? So what is the power transmitted? Power lost rather. Power lost is equal to I square R is equal to 150 squared into 0.4 ohms per kilometer into 20 kilometers, which is 150 whole squared into 8, which is 1.8 into 10 to the power 5, right? So this is the power lost. And what is the power originally put in? 6 into 10 to the power 5. So the percent lost is 1.8 into 10 to the power 5 by 6 into 10 to the power 5 into 100, or 1.8 by 6 into 100, which you can write it as 0.3 by 1, or 30%, which means the answer is B. Now in the next case, instead of sending it at that voltage, we actually increase the voltage, step it up, and then send it. So and the step up and step down, you know, in transformers is proportional to the number of turns. So the number of turns is 1:10, which gives us a voltage of, so initially the voltage is 4000 volts, and you put it in a transformer which has N in the ratio of 1:10, and it is a step up transformer, increases voltage. So the voltage will obviously become 40,000 volts, right? Because 10 times the number of turns. Then finally, when stepping it down, you need 40,000 to go to 200. So the ratio of the turns will be 40,000 by 200, or 200 is to 1, which means A is the answer to this question. Let's look at 13 and 14. We are given a charge Q rotating in a circle of radius r with an angular speed omega, and we are given that it can be considered equivalent to a loop carrying a current q omega by 2 pi, which is, if you were wondering where it came from, which is just q by t, right, where t is the time period. So this is the current, and the magnetic field increases at a rate of 0 to B in 1 second, right? So basically the magnetic field is B into t, where t is the time between 0 and 1 seconds, because it increases linearly. So what is the EMF induced in the loop? It is minus d phi by dt, right, is equal to minus d phi is the area into the magnetic field, which is the flux. Area is pi r squared into the magnetic field, which is bt by t, is equal to minus b into pi r square. Right, the sign at this moment doesn't matter, right? And this is equal to the electric field into 2 pi r, because we know the magnetic field is along the axis, so electric field will be in the circumferential direction, which gives us again, the sign really doesn't matter, we are just talking about magnitudes. So E is equal to pi cancels br by 2, which means the answer is B. We are only asked the magnitude of the electric field, induced electric field. So br by 2, which is B. Let's look at 14 now. The change in magnetic dipole moment is, and in the comprehension we are given that the magnetic dipole moment is gamma times the angular momentum. So delta dipole moment we are already given is gamma times delta angular momentum. So we can use this to solve it, right? So we need to know that angular momentum change, this is equal to gamma into, we are given that the radius of the circle is constant. So r square mr square I into delta omega. We need to find delta omega. Now the induced electric field will actually slow it down. The magnetic field cannot do anything to speed it up or slow it down because it doesn't do work, but the induced electric field can do work, right? So if the induced electric field is br by 2, that means the force, which is QE, which is QBr by 2, will be equal to mass into acceleration, which means the acceleration will be QBr by 2m, right? And we already know that it's going to try to slow it down. It should be a minus here, is going to try to slow it down because the induced electric field will be such that it opposes the change in magnetic field. Right, that's the way it works. So if Q is moving in this direction, the current will be coming towards the plane. If the magnetic field is towards the plane, then the induced electric field will be opposite to that, which will try to slow it down. Right. So in A is minus 2 pi r by m, it is equal to alpha r. Alpha is equal to minus QB by 2m, which means delta omega will be alpha into the time period. And what is the time period? Sorry, not the time period, the total time in which this change occurs. That total time is 1 second because the magnetic field goes from 0 to B in 1 second. So this is equal to delta omega because t is 1 second. So we get gamma into mr squared into qb by 2m with a minus sign. M and m cancels, which is minus gamma q r squared by 2. I'm missing a b here. B minus gamma r square b by 2, which is gamma r square bq by 2, which is option B. So the answer to the 14th one is option B. The 15th one. Now the 15th question is completely straightforward, 15 and 16, but you need to make sure you make the calculations properly, right? The basic point in that is this: if something like A plus B plus C forms D plus E plus F, then the mass of D plus the mass of E plus the mass of F should be smaller than the mass of A plus the mass of B plus the mass of C. If this mass is smaller, this energy is smaller than this, which means energy is released in the process. Any process in which energy is released happens on its own. Any process in which energy is absorbed, we need to make it happen. Right? So if this is true, that means it can occur, otherwise it cannot occur. So the first question is, the first option for 15 is, let's look at each option separately. lithium can emit an alpha particle. So that would mean 6,3 Li emits an alpha particle 4,2 plus what is left? What is left is a 2,1 hydrogen. Now you are given the masses of all three, and if we actually calculate the masses of all three, these two have a greater mass than this. If this has a greater mass, this has a greater energy, which means it can never happen. I'll write the equations for all of them. You can calculate the masses yourself. Right, 2H1 has a mass of 2.014102 and 4He2 has a mass of 4.002603. If you add them, it will be greater than the given mass of 6,3 Li. So B, polonium emitting a proton will be 210 PO84, which goes to 11 H, which is a proton, plus 20983 bismuth. You calculate the masses, you will see that this is again not possible. These two have a combined mass greater than this one. For C, deuteron and alpha particle, 2H1 plus 4He2 goes to 6Li3. Now you don't even need to do anything here. We've already seen that the first relation cannot occur because the mass of two of them is greater than the mass of the third one. So obviously this relation can occur. Right, this relation is possible. It's the inverse of the first relation. So C is true. And D is 7030 Zn plus 82 34 Se becomes 152.64 GD. You'll see that the mass of this is greater than the mass of these two, so it cannot happen, which means the answer to option 15 to question 15 is option C. Let's see question 16. The kinetic energy when polonium undergoes alpha decay. That's again straightforward. 21084 PO goes to 42He plus 20682 PB. If you calculate the all you need to do is, this is MP, let's just call it MPO. This has a value of 209.982876, and these two have a value of MHE is 4.002603. MPB has a value of 205.974455. So the answer will be, the answer will be, we'll add these two together. That gives us 209.977058, and we subtract it from the first one. That will give us delta M, which will be 0.005818, and we'll just multiply it by C square to get the total energy, which will be delta M C square, which is this multiplied by 932, which is 5422 kilo electron volt. This is the energy. Now this is not the final answer, right? This is where some people might make a mistake. This is the total energy given, right? That means this is the kinetic energy of helium plus the kinetic energy of this term. Both of them have a kinetic energy, but both of them will have the same momentum because of momentum conservation, right? So the momentum for both of them, let's call it P. Then the kinetic energy for this will be P square by 2mHe, and this will be P square by 2mpb. And the sum of the two of them will be this value, let's say alpha. And if P is the same, then what will be each of those two terms? Right, they will be inversely divided in the ratio of the masses. So the first term, let's say this is A, this is B, right? So the first term will be alpha into, see, this is much greater than this, right? So this will have a greater contribution. So this will be M times PB. You can just straight away solve it, but I'm used to doing it like this, by MHE plus MPB, which is equal to whatever this energy is into the mass of PB by the sum, 206 by 210, which gives us exactly 5319, which is option A. So this is the important thing. You calculate. This is why they gave the question, I think. Otherwise, it would be too easy to come in IIT JEE. But you just see this, and you see that this is the total energy divided in the ratio of MHE and MPB, such that momentum is the same. So you calculate the kinetic energy of just the alpha particle. Most of it will be the kinetic energy of alpha particle, but a little bit will go into the kinetic energy of lead as well. Right? Let's move on to these match the following questions, starting with question 17. We are given a graph, PV curve, E, F, G, H goes like this. This is 32 P naught. This is the PV curve, which is nice. Whenever we try to get, whenever we get another graph, we change it to PV because that's easier to work with. P naught, V naught. This is H, right? Now we are given that all these processes are isochoric, isobaric, isothermal or adiabatic. So obviously this has a volume constant isochoric, this has a pressure constant isobaric. One of these two is adiabatic and one is isothermal, right? And we know the larger slope is the adiabatic one. So this is the adiabatic one and this is the isothermal one. From that we can directly say, if this is 32 P naught and V naught and this is P naught, then this point is 32 V naught. That we can directly see. Now we need the work done in all the four cases. Let's talk about P first. In P, we need G to E. G to E, the work done will be 32 V naught to V naught. So it will be, and we need the magnitude of work done, right? So it will be minus 31 P naught V naught, but basically 31 P naught V naught, because we need the magnitude. Q is G to H. G to H. Now G to H would be interesting. We need to calculate parameters for H, right? So from here and here, we can use PV to the power gamma is equal to constant. Gamma will be equal to 5 by 3 because it's a monoatomic ideal gas. So what we'll get is 32 P naught. So this goes to option 4. 32 P naught V naught to the power gamma is equal to P naught V to the power gamma, and gamma is 5 by 3, which means that V is equal to V naught into 32 to the power 3 by 5, which is 8. So it is 8 V naught. So this is 8 V naught. So now we get the work from G to H. This is 32 V naught, this is 8 V naught, isobaric, 24 V naught. So it is 24 P naught V naught, which goes to option 3. Right. Then let's take R. R is F to H. F to H is an adiabatic process. We know what the work done is. P1 V1 minus P2 V2 by gamma minus 1. So 32 P naught V naught minus 8 P naught V naught by gamma minus 1 is 2 by 3. So 24 by 2 by 3 is 24 into 3 by 2, 32 P naught V naught. So that is option 2, 36 P naught V naught. That is option 2, 24 into 3 by 2. Which means that S has to be option 1, which means the answer has to be A, but it's a good idea to see S anyway. Work done in F to G. That is nRT ln V2 by V1 or PV ln V2 by P1. So 32 P naught V naught ln V2 by V1, 32. So 32, and this is 2 to the power 5. So 160 P0 V0 ln 2. So indeed the fourth one does give what we would expect, and the answer to this is option A. Let's do 18th. 18th is pretty easy, we can directly see. All we need to do in list 2 is complete the equations. Right. So 1508 goes to 157n. Right. In this case, you have one less atomic number but the same atomic mass. So obviously in this case, a proton gets converted into a neutron. And if a proton gets converted into a neutron, it gives you a positron plus a neutrino. Right. So this is the first one. Then you have 23892U goes to 23490TH, and obviously it has to be added with 42He, an alpha particle. Right. Then you have 18583Bi goes to 18482Pb plus what is left? 1 and 1. So 11H is left. Right. And finally you have 23994 Pu goes to 14057 La plus something else big, something like this will be 99 and this will be something, so another big thing. So alpha decay is the second process, so P goes to 2. Q beta plus decay is the first process, so it goes to 1. Fission is the fourth process. Heavy nuclei breaks into 2 medium nuclei. This is 99, so it's a medium. So R is 4, and S, proton emission, is this one, which is 3. So 2143 gives me option C. Let's move on to problem 19. It should be right angled one, sorry. This is mu1, mu2, mu3. This is our incident ray E. It goes straight here, and then here is the normal, and after that it can go like this, or straight through like this, or it can go like this, or it can go like this. Come back. If this is 45, this is 45, this is 45, this is 45, all are 45. And after this, the first one they're making it go like this, and the second one is going straight out, and the third one is going like this. So let's just look at what we can do for all of this first. This is E, this is I, sorry. This is F, G, H. So first of all, what is true for G? For G, or for E to G, mu1 has to be equal to mu2. There is no change here, right? You obviously have an incidence angle of 45 degrees and you have a reflected angle of 45 degrees as well, right? So you have no change. So for G, mu1 has to be equal to mu2. So Q goes to 3. Right. After that, let's look at the others. What happens in I? in I you need to have total internal reflection, which means mu1 times sine 45 has to be greater than mu2, right? Because then mu2 sine theta will never be able to achieve this. It has to be greater than mu2, right? In which case mu1 has to be greater than root 2 mu2. If this is the case, mu1 sine 45 will never be mu2 sine theta for any theta, right? So mu1 greater than root 2 mu2, which is 1. So S goes to 1. From that you can directly see that option D is correct, but we'll do the other ones also, obviously. So now we need to differentiate between between F and H. Right, between F and H. So in both of them, mu3 is less than mu2. Right, both for F and H, mu3 is less than mu2, because this is going away from normal, but that doesn't help us anywhere, because options 2 and 4, which are the options left, have mu3 less than mu2. So that is established, mu3 should be less than mu2. Then now we need to look at between mu1 and mu2. Right, so this is 45 degrees. This angle alpha is less than 45 degrees, as this total angle beta is greater than 45 degrees. So obviously mu1 sine 45, mu1 by root 2 is equal to mu2 sine alpha or whatever beta you want to have. Right, now sine alpha is less than 1 by root 2. If sine alpha is less than 1 by root 2, mu2 has to be greater than mu1. And if sine alpha is greater than 1 by root 2, then mu2 has to be less than mu1. Right, so this is sine alpha less than 1 by root 2, which means F. So F has mu2 greater than mu1, which means option 2. So P has option 2, which means R should have option 4. So R does have mu2 less than mu1, but it also has mu1 less than root 2 mu2. Now what is that about? Well, if mu1 is greater than root 2 mu2, then we would have total internal reflection and it would become I. Right? So mu1 has to be greater than mu2, but it has to be less than root 2 mu2, otherwise there would be total internal reflection, which we don't want. So this gives us, again, we already got D from Q and S, which were the easy ones, but all of those seem consistent and the final answer is D. Let's look at the final 20th question, and this is a pretty simple question. It's just standard dimension analysis. So we just have to calculate the dimension of all of them, and any one formula will do. So for the Boltzmann constant, I just use the formula that the dimension of KT is the dimension of energy. Energy is ml2 t to the power minus 2. Right, this is KT. So what is K? Boltzmann constant, ml2 t to the power minus 2 k minus 1, which is 4. So P is 4. Q is coefficient of viscosity. I like V is equal to 6 pi, which does not have any dimension, eta RV, which means mlt minus 2 is equal to dimension of eta times L times lt minus 1, which means eta is equal, dimension of eta is equal to m. You have two L's here, one here, so L minus 1 t minus 2. Sorry, t minus 1 here and t minus 2 here, so ml minus 1 t minus 1, which is 2. Then you have R, which is Planck constant, which is, again, I just remember h mu is energy, which is ml2 t minus 2, and mu is 1 by t, so this is ml2 t minus 1, which is 1. And S, which is thermal conductivity, so Q by T is equal to Ka delta theta by L. A by L I can just write it as L because A is L square. Q energy is ml2 t minus 2 and by T is t minus 3. right? LL cancels, so we get MLT minus 3 K minus 1, which is 3. So 4213 gives us option C. So the answer to this last question is option C. This completes the solutions to Physics Paper 2 of 2013 JEE Advanced. Thank you.